All right, we're back. We are in Notes 23, talking about slope fields, Calc AB. And let's get started. We're on page 9, and all the previous pages have been done in other videos, so here we are. So when you're dealing with differential equation of more than one variable, so x and y will appear in the differential equation, like it's not the case that you look along horizontal lines and you get the same slope. Vertical lines get the same slope. The slope's going to vary as you move around your slope field. So you need to have strategies to use for that. Oftentimes, figuring out where the slope is 0 is enough. So in this problem, we need to decide which is which. We have dy dx is x plus y, or dy dx is x minus y. We have two slope fields we want to choose. So I'm going to choose based on where the slope is equal to 0, I think. So where is the slope equal to 0? Slope's equal to 0, I don't know. All right, so here's what I'm going to do. I'm going to take dy dx equals x plus y. So I'm going to do it over here. If dy dx, well, no, I shouldn't do it over here because I'm not actually sure which is which, although I pretty much am sure. I'll do it up here. If dy dx equals x plus y equals 0, then y equals negative x. Whereas if dy dx equals x minus y, then dy dx equals 0 would mean y is equal to x. Okay, so now you go to your slope field and you look along those lines, right? So for example, I think it's more, I don't know why I feel like it's more obvious here. Along this, we can see dy dx is definitely equal to 0, and that's the line y equals x. So this must be dy, therefore, this must be dy dx equals x minus y, which I do all the time. Whenever it's like choose between the two, they're always like in the same exact order. Here, we would want to fill in. So look for the 0 slopes and then just kind of, look at that. Look how unsteady my hand is. That's my best shot at a straight line. It's not great. So I don't want people chiming in with all the disorders I might have, but I do not have very steady hands. dy dx is x plus y. Okay, so, and I mean, that's probably good enough, but I like to do a little bit of extra stuff. So another thing that I think is interesting is if we find the second derivatives. So I'm actually going to do that down here. So since we now know that dy dx equals x plus y for this, equals x plus y. That's weird. I don't know what I was doing there. I thought it was going to be a fraction maybe. So then the second derivative is going to be 1 plus the derivative of y is dy dx. That's like the whole idea here. It's dy dx. But since I know that dy dx is x plus y, I can make my substitution. So that'll be 1 plus x plus y. Okay, so now linear functions have 0 concavity, right? So what I can do is I can use this. I can say this equals 0. That means that y is equal to negative x minus 1. If I go up to my slope field and I look for the line y equals negative x minus 1, so that's going to be here, and then also here. You can actually see by finding the second derivative, you can figure out which is which, because over here, it's obviously not the case. I could do the same thing here. So if I take dy dx equals x minus y, and then, I mean, there's a lot of other things I could do here. I could figure out when the solution, just, so for, let me finish this before I have 3,000 other thoughts. Second derivative, 1 minus dy dx. So then make our substitutions. It's 1 minus quantity x minus y. So that's 1 minus x plus y. So if I set it equal to 0, I would get y equals x minus 1. If I go up to my slope field and I look for y equals x minus 1, so here's this. So this is another effective way of doing this. Now, I think that for this particular slope field, another really good strategy to decide which is which is take, for example, where am I looking? Take like anything on the y-axis, basically, right? So take 0, 4. 0, 4. For each of those, so for the left-hand one at 0, 4, the slope is definitely positive. For the right-hand one, at 0, 4, the slope is definitely negative. Just substitute those in. You would know the difference between them right away. So that's like always an option, but it's not the most intellectual of options. Like that's just substituting and checking. So I like to give you other ways to think about it too. All right, let's look at this. So we have one slope field, we have two differential equations. We're going to try to decide which is which it is, and why. So what could we do? I mean, so one strategy is to look for slopes that are 0. When the slope is 0, I think we are on, so kind of like here. So it's a little dicey. Oh, God. Okay. Like, is that, so I think that the equation of this line, I think would be, so I think dy dx equals 0 when y is equal to, so that looks to me like -1 plus x, I think. -1 plus x. So let's check and see. So for the first one, for this one, I'm going to check. So like here, dy dx such that y equals, let's say x minus 1, would give me x minus 1 minus x plus 1 would give me 0. Okay, so strong evidence to suggest that that's it. But what about, let's see, this one? Sometimes I try to color code it like this, where it's just like a little easier maybe. I don't actually know if that's useful. I think it is, but so here dy dx such that y equals x minus 1 would give me x minus 1, because I substitute for y, minus 2x minus 1, which is actually -2x minus 2, not 0. So that's definitely not it. So we actually were able to identify this just based on that. So I'm going to say based on this, therefore, dy dx is definitely y minus x plus 1. So what else could we do? We could find the second derivative and set it equal to 0 and see where we get a linear solution. So how would we know the linear solution? We'd be looking for our second derivative to equal 0 along this line. And this line is definitely y equals x. So we could find the second derivative using implicit. That's a great strategy. Another strategy that we could use, I'm thinking that, so if x is 0 and y is, I don't really know. I mean, like you can, at this point, you could just start picking points. I tend to just pick like at 0, 0, for example, for this this curve at 0, 0, you would get 1, and here at 0, 0, you would get -1, and right away you knocked it out. You know immediately that it's y minus x plus 1. You got like a lot of strategies. I'm partial to that second derivative one because I feel like it answers a lot of questions along the way, but it doesn't really matter. And it looks like that's the end of this page, so I'm going to let that be the end of this page. What types of solutions you get? 3 types of solutions. I'm apparently not going to let it be the end of this page. You get 3 types of solutions. You get, if you are above the line y equals x, it looks like you get concave up increasing solutions. If you're below the line, it looks like you get concave down with a relative maximum that always falls on the line y equals -1 plus x. These are all the things you should be thinking about as you're working your way through these. But anyway, I am going to end it here, and I will come back in the next video, and we will do a little bit more. So I will see you there.